Physics Lab 4. Introduction and Purpose. This lab is intended to predict the motion of a spring mass system, compare collected data to computed models, and relate the physics principles demonstrating that the system exhibits conservation of energy. The physics principles used in this lab are Newton's second law and the energy principle. The system is the mass, spring, and the earth while there are no surroundings. Software used for analysis. GlowScript is used for this experiment to calculate a theoretical model of the spring mass system and compare it to the collected data and model both data sets. Trackers used to follow and plot a mass as it follows a path and collect data points for that data set. In this experiment, I found that both the observed and computational models follow the energy principle. This is my tracker and data. On the left shows my data points from the video, and on the right shows them on a graph or a chart. And these are my physics equations and calculations. The top two formulas are the position and velocity update formula used to find the new position and velocity for each data point, and the four equations in the bottom left are the kinetic energy formula, the potential gravitational energy formula, the potential spring energy formula, and the total energy formula. Uh, Total energy is defined as potential spring energy, potential gravitational energy, and kinetic energy combined. The initial conditions for this experiment, we set time to 0. We set the initial velocity to 0 meters per second as it's supposed to be released from rest. The mass was given at 0.402 kilograms. The spring constant is 6.83, and we were also given the relaxed length of the spring to be 0.123 meters. Given it's also the initial position of the mass. These are our results. The top left shows the change in energy versus time. The orange shows that delta E remains 0, showing a conservation of energy, adhering to the energy principle. The two graphs in the bottom, the left is the Y position and the right is the X position. For both the model shown in blue and the experiment shown in red, in the Y position, it shows that the experiment moved less in the Y position than predicted in the model, and the opposite on the X direction as the object moved more in the X direction than predicted. GlowScript analysis. The top right sets the initial constants like gravity and spring constant while also calculating initial energies and initial spring stretch. The spring length is given by ball position minus spring position. The direction is given by that length divided by the magnitude of the vector and the spring length at a certain time. The stretch is given as the magnitude of the length minus the relaxed length of the spring. On the bottom left, calculates the forces and updates position and velocity. It also calculates the change in energies, which the change in each energy is just the energy final minus the energy initial, such as total energy final minus total energy initial. Possible errors and what-ifs. Possible errors include that I might not have chosen the center of mass correctly for each data point. There could have possibly been unanticipated forces such as drag, and perhaps there was an initial velocity and it wasn't perfectly released from rest. What does it mean? The energy principle seems to indeed be satisfied as delta E on the plot stays at constant 0. This notes that the conservation of energy did take place and that energy was just transferred from the various types of potential to kinetic and back and forth. This is noted by summing at any time point all three types of energy, you will always get 0. And for our what ifs, the time of oscillation period derived from the x data point is approximately 1.614 seconds, while from the y data point is approximately 1.519 seconds. This could be due to a shift in the oscillation as it rotates from more horizontal to a vertical oscillation.